Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. How do we derive an equation? Do we have to remember all the equations? No. We should be able to quickly derive by applying the right concept. In the process of deriving, automatically you will remember certain equations. Let me give you an example of projectile motion. Projectile is a body which is thrown with some initial velocity u at some angle theta with the horizontal. So it executes two-dimensional motion, a parabolic path as shown in the figure. We can mathematically prove that the trajectory of the projectile is a parabola. Now, how do we derive various things of the projectile like time of flight, range, the maximum height attained by the projectile, time of ascent, the time for which it is ascending, and time of descent, the time for which it is descending. All these things we can easily derive by applying the concept in a right way. The initial velocity has got two components. The horizontal component is u cos theta, and the vertical component is u sin theta. So let me write it neatly. So u sin theta. Suppose there is only u cos theta component, there is no u sin theta. Forget about u sin theta. There is only u cos theta. There is no force on the particle in the horizontal direction. There is no acceleration in the horizontal direction. There is nobody to disturb u cos theta. So the particle moves in a straight line with the constant speed u cos theta. It is uniform motion along horizontal direction. Now forget about u cos theta. Suppose there is only u sin theta. Then it is like a vertically projected body. It goes to certain maximum height with decreasing velocity. Velocity becomes zero. After that, it returns back to the point of projection. Now both are happening simultaneously. It is going up and coming down. Simultaneously, it is moving in the horizontal direction. So the path is the parabolic path. It has covered certain maximum horizontal displacement, which we call it as range. The maximum horizontal displacement of the particle, of the projectile, is known as range. During its trajectory, it has attained a maximum vertical displacement, which is known as maximum height, h max. And from the point of projection to maximum height, it is time of ascent. From maximum height to ground, again, it is time of descent. The sum of these two is time of flight. Let us get the equations. So to solve this, in the vertical direction, the acceleration is g downwards because it is a freely suspended particle in air. The only force acting on it is its own weight. So the acceleration experienced by the particle is g downwards. Let us split the motion into two parts, along x-axis and along y-axis. So this is along x-axis. I'll write the equations of motion. And along y-axis, along x-axis, initial velocity ux, that is equal to u cos theta, and ax, acceleration, which is 0. There is no acceleration in the x direction. So velocity at any point of time vx, that is simply u cos theta. This is the first equation. And the horizontal displacement at any point of time, that is u cos theta into t. Then plus half a t square, that is 0 because ax is 0. Very, very important thing that you should notice in case of projectile motion is that the horizontal component of its velocity remains constant. So at this point, for example, horizontal component is u cos theta. Vertical component has slightly decreased. Initially it is u sin theta. Now it's going on decreasing. So it is this. At this point, horizontal remains u cos theta, but the vertical has decreased. At the maximum height, the vertical component has totally become 0, but horizontal component u cos theta remains as it is. After that, u cos theta remains as it is. In the vertical direction, the velocity starts increasing. So after some time, u cos theta is same, vertical component increased. Finally, also u cos theta did not change. Now it has finally become u sin theta in the vertical direction. For the simple reason that if you throw a stone with a speed u up, it will come back with speed u. Right? So you can easily prove that. So by the time it is coming back, so the velocity in the vertical direction will be u sin theta. Because it decreased at the rate of g, then it increased for the same time at the rate of g. So velocity in the vertical direction would be u sin theta ultimately, finally. So this is the meaning of Vx is equal to u cos theta. Everywhere it is u cos theta. At the maximum height, what is the velocity of the projectile? It is u cos theta. It is not zero. What is zero at the maximum height of a projectile is only the vertical component. There are several questions that can be asked based on this concept, that the horizontal velocity of the projectile remains constant. I will do a separate video on all the possible questions that can be asked based on this concept of horizontal velocity of the projectile remaining constant. Now, at the maximum height, the vertical component is zero, it is still having u cos theta. Let me write equations along y-axis. Uy is u sin theta, up ay is g, down, so vy, I'll use u sin theta minus gt because uy and ay are in opposite directions, and displacement y is u sin theta t minus half gt square, and the third equation v square is equal to u square sin square theta minus 2gy. These are the equations governing the vertical motion of the projectile. That's all. Using these equations, using some mathematical calculations, we can derive different things. Firstly, let us derive time of flight. Time of flight is nothing but that time when it is hitting the ground. So the vertical displacement has become zero. Horizontal displacement is range and vertical displacement has become zero. So from this equation, y is equal to u sin theta t minus half gt square. The value of y, vertical displacement, becomes zero. So x comma y, x and y are basically coordinates of the projectile at any point, taking initial point of projection as origin. X is the horizontal displacement, y is the vertical displacement. So 0 is equal to t into t, I can take common, u sin theta minus half gt. It's a quadratic. There are two values of time which satisfies this equation. T is equal to 0 or t is equal to 2u sin theta by g. So t is equal to 0 is the initial point of projection. Obviously, initially when you are about to project, the displacement is 0. This is one time, and another time where the displacement is 0, vertical displacement is 0, is 2u sin theta by g, which is time of flight. So the expression for time of flight is 2u sin theta by g. Time of ascent. Time of ascent is that time when the vertical component of velocity is 0. So this would be the right equation connecting vertical component of velocity and time. Quickly substitute Vy 0 is equal to u sin theta minus g. Time becomes Ta. So that implies time of ascent is u sin theta by g. Time of ascent plus time of descent is time of flight. So Ta plus Td is Tf. Obviously, time of descent is also u sin theta by g. 2u sin theta by g minus u sin theta by g, that is u sin theta by g. So time of ascent is equal to time of descent. The time for which the projectile ascends is equal to time for which it descends. You can observe from these equations. And now range of the projectile, you can use this equation, range of the projectile. So I'll do it here. Yeah, so x becomes r when t becomes time of flight, u cos theta into time of flight. This is one expression. It is u cos theta into time of flight is 2u sin theta by g. So another expression of range is 2 times u cos theta is ux, u sin theta is uy by g. Very simple. 2ux into uy by g. For example, a projectile is thrown with initial velocity as 3i cap plus 4j cap. What is the range of the projectile? It is very easy to solve. So horizontal and vertical components are given 3 and 4. So 2 times of 3 into 4, 2 times of 12, that is 24 by g, that is 10, 24 by 10, 2.4 meter. That is the range of the projectile. 2 into ux uy by g, or you can use u cos theta into time of flight, or you can also express range as u square sine 2 theta by g. Another way of expressing range is u square 2 sine theta cos theta. So from this, 2 sine theta cos theta is sine 2 theta by g. This is range. And how do we find the maximum height? For maximum height, I can use this equation. At maximum height, vertical component of velocity is 0. So that is equal to u square sine square theta minus 2g h max. So maximum height of the projectile is u square sine square theta by 2g. U square sine square theta by 2g. This is the expression for maximum height. This is the way we can derive any equation that we want. All we should have is that conceptual understanding and clarity. I'll come up with another such interesting videos. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.